What science is about is finding out what is true in the real world.
If you can't prove it impossible, then how can you say it's likely that it's unlikely? Well, that's the way, that is scientific. It is scientific only to say what's more likely and less likely, and not to be proving all the time possible and impossible.
Because science informs us of what the real world is.
Notice, however, we never prove it right. Suppose that you invent a good guess, calculate the consequences, and discover that every consequence that you calculate agrees with experiment. The theory is then right? No, it is simply not proved wrong.
What you want is objectively verifiable truths.
So we never are right, we can only be sure we're wrong.
Because science informs us of what the real world is.
You're absolutely right if you're going to tell me science can never tell anything with absolute certainty.
Yeah. What science is about is finding out what is true in the real world.
Science can never tell anything with absolute certainty.
Yeah.
If you're interested in the ultimate character of the physical world, of the complete world, and at the present time, our only way to understand that is through a mathematical type of reasoning. Our only way to understand.
So I would like to discuss this with you. Will you please keep coming in spite of the fact that you don't understand it? Because I don't understand it either. And the fun of it is that it's so mysterious, okay? That's the fun of it.
On the other hand, I think I can safely say that nobody understands quantum mechanics.
Our only way to understand that is through a mathematical type of reasoning.
On the other hand, I think I can safely say that nobody understands quantum mechanics.
I know what it means to know something.
Science can never tell anything with absolute certainty.
Yes.
But the key part of what makes science science and what makes it work is it's based on empirical evidence. Sort of rational thought applied to empirical evidence.
Don't keep saying to yourself if you can possibly avoid it, but how could it be like that?
It's so mysterious.
Rational thought applied to empirical evidence.
I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do.
Because science informs us of what the real world is.
If it disagrees with experiment, it's wrong. And that simple statement is the key to science.
But the key part of what makes science science and what makes it work, I hear that a lot, and it's one of the biggest misunderstandings of nature science is that scientific revolutions do away with what was before them. That's precisely not how scientific revolutions work. They always keep what worked before them. Einstein may have overturned Newton in a sense, but Newton's laws of gravity still describe the motion of a baseball.
People, if you base the design of planes on science, they fly. If you base the design of rockets on science, they reach the moon. It works. Bitches.
The point is, though, that the two theories, although they sound different at the beginning, have all consequences the same. It's easy usually to prove that mathematically by doing a little mathematics ahead of time to show that the logic from this one and this one will always give corresponding consequences. Suppose we have two such theories, how are we going to decide which one is right? No way, not by science, because they both agree with experiment to the same extent. There's no way to distinguish one from the other. If it disagrees with experiment, it's wrong. And that simple statement is the key to science.
They always keep what worked before them.
It works. It works. It works.
For those people who insist, however, that the only thing that's important is that the theory agrees with experiment, I would like to make an imaginary discussion between a Mayan astronomer and his student. The Mayans were able to calculate with great precision the predictions, for example, for eclipses and the position of the moon in the sky, the position of Venus, and so on. However, it was all done by arithmetic. You count certain numbers, you subtract some numbers, and so on. There was no discussion of what the moon was. There wasn't even a discussion of the idea that it went around. There was only calculate the time when there would be an eclipse or the time when it would rise, the full moon, and when it would rise, half moon, and so on. Just calculated only. Suppose that a young man went to the astronomer and said, I have an idea. Maybe those things are going around, and there are balls of rocks out, like rocks out there. We could calculate how they move in a completely different way than just calculate what time they appear in the sky and so on. So, of course, the Mayan astronomer would say, yes, how accurate can you predict eclipses? He said, I haven't developed the thing very far. He says, but we can calculate eclipses more accurately than you can with your model, and so you must not pay any attention to this because the mathematical scheme is better. And there's a very strong tendency of people to say against some idea, if someone comes up with an idea and says, let's suppose the world is this way, and you say to him, well, what would you get for the answer for such and such a problem? And he says, I haven't developed it far enough. And you say, well, we have already developed it much further, and we can get the answers very accurately.